Okay, what we have here today is a B&K model 2050 RF generator. This generator will generate output anywhere from on band A about 100 kilohertz up to about 30 megahertz on band F. It does that in 6 ranges, A through F. It has an adjustable RF output, continuously adjustable via this dial. We also have an output attenuator switch for both low and high output ranges. We have an internal and external modulation switch and the power switch. Your signal comes out of these test leads here. The vernier is a really nice mechanism. It's a geared vernier drive. Works in reverse of what you think. If I want to turn up, I have to turn down. I turn to the left. But as I turn to the left, this geared mechanism takes place, and I get a really nice, smooth movement of the dial throughout the frequency range. Okay, we're going to take her all the way up here and run through some range tests just to give you a look at the output, and then we're going to do some spot checks of the frequency accuracy of the dial. Okay. Okay, we're going to start on band F and work our way from the top of the frequency generator's capability to the lowest. So we'll be watching this oscilloscope screen. I'll hold this steady as I can here. And we're going to look for the signal itself. We're going to try and look for a clean, recognizable sine wave signal and observe any distortions that might happen and dropouts and that sort of thing. So right now we're on band F. Band F covers 10 megahertz through 30 megahertz. We're on the 30 megahertz end, and we're going to start sweeping down. You'll see the waveform start to expand as the frequency goes down, and you'll also see the amplitude change as we sweep through the various efficiency points of the oscillator. Okay. And then somewhere around 10 megahertz we should drop out. Okay, there we go. Alright, so that's 10 megahertz again. Let's go back up to the maximum of the range. Okay, and we will put our amplitude down a little bit. We're now on band E. Band E covers 4 megahertz through 11 megahertz. So we're on the 11 plus side right now and going to drop. Once again, observe the waveform, and I'll adjust the amplitude, try and keep it on the screen. We're getting more efficient as we get into these lower frequencies here. I'm going to go ahead and step my my time base down a little bit so we can see more of the waveform. Alright, and we're going, that's at the end of E, we're going to band D now. Go ahead and on band D we cover 1.5 to 4 megacycles. And let's get ourselves up to the top end quickly here. There we go. We're coming at the 4 megacycle end and then working our way down. Alright, and we hit the end of range. Go to band C. Well, let's go ahead and kick ourselves up first. Band C. Band C is 550 kilocycles to 1.5 megacycles. We're at the 1.5 plus side right now, and we're going to work our way down again. Okay, that was it. And let's get to band B. 250 kilocycles to 650 kilocycles. So we're at the 650 plus side, and we're going to work our way down. And we're at the end there. Go ahead and kick this thing down a little bit, give ourselves some range. We're going to band A. Let's start at the max side. And band A covers 100 kilohertz to 250 kilohertz. Ourselves on the screen. And as I sweep down, we're at 250, working our way down to 100. There we go. So we've covered all the ranges. You've seen the output. It looks nice and clean. We had one dropout point at about below 10 megahertz, and that was on band F. But 10 megahertz happens to be the end of band F, or the low end of band F anyway, so you really shouldn't expect to receive too much below that. You go instead to band E and catch over the point there, because band E excuse me, covers 9 through 11 megacycles on that upper end anyway, so you pick it up there. Let's now check the accuracy of the dial and see. We'll use our frequency counter to do that. I didn't use the frequency counter during this measurement period because I didn't want it to load the system and provide some distorted looking signals. The counter does load, any counter will load a circuit, and it will provide some additional odd looking load changes to the output. Okay, let's see, we're going to go alright. I've now get this light out of the way here. I've hooked up my counter, and we are on the low end of band A, reading 93 kilohertz at the moment. We're off the dial on the generator. We're going to raise the dial to the 100 kilohertz mark, and I'm going to say that that's right about there. And we look at the counter, and it's 100.4. That is as close as I can get the start point looking at it, eyeballing it. Let's take ourselves up to what looks like it should be 150. Oops. Just knocked my ground off here. Hang on. There we go. Alright. I'm going to raise it up to about 150 kilocycles according to the dial, and I am reading 149.4. Pretty darn close. I could have eyeballed it maybe a little better. Got 150. Let's go ahead to the upper end of band A, which would be 250, and I would say that's right about there. It's reading 247. So a little tweak to it, and we would have 250. Very minimal change, and I get 250. Okay, let's go to band B. Band B starts at 650 on the dial, which I assume is right about there, and I'm getting a frequency counter reading of 647.7. So within 3 kilohertz accuracy, just eyeballing it on the dial. Very good. Let's take ourselves down to about mid-range, which would be about 400 kilohertz. I'd say that'd be about it there. 404.5. Little tweak on it here, and just a small tweak, a nudge. I got 402. So anyway, let's take her down to the low end of band B, and that would be 250 kilohertz. Appears to be right about there. 252.8. Go to band C. Okay, band C would start right about the same point on the dial. I didn't have to move it. And it should be 550 kilohertz. We got 552. Let's take her up to mid-scale on band C, which would be, say about 900 kilocycles. Puts her up right about there. And I'm reading 906.8. Little nudge on the dial. And the difference is very minimal on the dial, but yet much within 2 kilohertz or 1 kilohertz of the 900 mark. Take ourselves up to the end of C, which would be 1.5 megacycles. Right, looks like it's right about there on the dial, and it's 1.499. Very, very close. Pop my ground again. Okay, band D. The end of band D would be right about here. That should be about 4 megacycles. 3.98. Okay, let's take ourselves to the mid-range of... It's frustrating. Okay, let's once again, let's take ourselves to mid-range of band D, which would be approximately 2.5 megacycles, and we're reading 2.52. Again, we're just eyeballing it off the screen. Let's take ourselves to the low end of band D. Should be 1.5 megacycles, and I'd say that's eyeballing it, that's about right. And by golly, it's 1.51, so I did a good job there. Band E would start actually right in about the same area. Should be 4 megacycles, 3.98. Take ourselves up to the mid-range at about, we'll say 6 here on the dial. Looks to be 6, and it does give you 6. So that's pretty amazing. And once again, going up to the upper end of E. You might be thinking I'm using the counter, but I'm not using the counter. Trust me. I'm simply looking at the dial and trying to get the needle over top of the number. So I should be setting at 11 megahertz, and I am running at 11 megahertz. That's really pretty good on that particular reading. Let's go to band F. Okay, F at 30 would be right at the end of the, right out there. Okay. And we are running about 30.2. Okay. I'm going to go ahead and turn this RF output all the way up. My sensitivity on the counter is loading it, so we're going to need the extra. I want to go to mid-range on this particular scale. I would say that would be approximately there would be about 16 megacycles, and we are reading 16.2. So again, I did a good job. I got to be careful on the low end here because I know band D drops off at about 10 megacycles. It didn't fall out. Let's take it right to 10. Okay, there's 10 right there on the dial. And we've got and right there on the frequency counter. So that turned out very well. So there we go. We've spot checked the vernier dial. The vernier is quite accurate. Not much more than a couple of percent, even in the worst case. And it's got a nice clean output. We've looked at that. I'd say you're going to be quite happy with it. So, got a little bit of reflection happening from my counter right now. We have internal modulation. Let's go ahead and demonstrate that. We'll take the counter off of here so that we're not loading the system. No need to anyway. I'm done with that. You have a modulation switch right here. If I go to the left, that's for external modulation. You can feed a signal in. Modulate your voice and broadcast it if you wanted over a table model radio. Might be a fun little experiment for somebody. Or you can go internal modulation. You get I think it's a 400 hertz tone. I can move the switch here. There we go. And when you turn on the modulation, it looks something like that on the screen. Oops, I turned the power switch off. Try that again. There we go. Not modulated. Modulated. Okay, so you see the ends of the waveform. That's where we're modulating the high frequency wave with the low frequency. So up, we're amplitude modulating the wave. So what's happening is we're going from the bottom of that. If you looked at the top of the wave, if you looked at roughly this point of the wave, from here to the top of the wave, that's the amplitude of the signal coming in, the 400 hertz. 400 times a second, we're vibrating up and down on that waveform. Same on the bottom end. That's the modulation. And we can also look at the modulation differently by going to the 400 hertz area and looking at just the envelope. And we should see that 400 times a second, the envelope is. So now what we're looking at is the high frequency modulating the low frequency envelope. It's another way of looking at it. If you look at the low frequency end of things, 400 times a second, we're vibrating here. So you can imagine the cycle happening here, but well, right now we're at about 10 megacycles, so about 10 million times a second. We're modulating the envelope so that you can't even see the cycles in between, but you can see the upper and lower boundaries of the waveform displayed 400 times a second. Well, anyway, so that's the modulation. If I kill the modulation, we go flat again, and we're back to the 10 megacycle output, which we should be able to lock in on. There we go. So it's a very nice looking unit. It's got a very clean front panel. Glossy, no scratches on the lens, no scratches in the paint. It looks actually, could have been new. It looks like it might be maybe a year or so old at most. Doesn't look like it's an older unit. It's all solid state. As I said, I'll provide this unit with a set of test leads and a manual. The manual gives you the instructions how to use the unit. Some of the specifications are in it. Usage of the circuit in troubleshooting. And radio IF adjustments, and we should be getting up to a parts list and a schematic. There we go. So we've covered all the bases. you'll be set with a really nice unit. Good luck.